symbol is ampersand symbol. In this way it is denoted, the AND operator. So what the logical AND operator gives, suppose assume there is an expression, okay. In that expression there are so many conditions, 5 conditions or 10 conditions or 100 conditions are there. If all that conditions are true, then only it gives the result as true. Getting it? The logical AND operator. If at least one condition is false means it gives the result as false. Okay. So when it gives true, when all the conditions in a given expression are true. If at least one condition among that is false means it gives the result as false. Otherwise, if all the result are false or if all the condition are false means then also it gives the result as false. Getting it? So that is the work of AND operator. It gives true when all the conditions in a given expression are true. Okay. So you can write down. It gives logical value true if all conditions if all conditions in a expression are true. If all conditions in a expression are true, comma. Otherwise it gives false. Clear? So when it gives true, if all conditions in a expression are true, otherwise it gives false. Okay. Suppose assume we denote 1 for true, suppose, and we denote 0 for false. Okay. Suppose there are 2 conditions in an expression, then let us see how it will work. Suppose there is a condition like this. Condition 1 C1, condition 2 is C2, R is the result. Suppose there are 3 columns. If I perform AND operation between C1 and C2, if I perform AND operation, if this is true, condition 2 is false, then result will be what? False.
False.
If condition 1 is true, condition 2 is also true, then the result is true. If this
True.
is false, this is false, then the result will be
False.
false. Suppose one is false, another is true, then the result will be
False.
false. So clear? So when it gives the result as true, when all are true,
False. True.
otherwise it gives false. Okay, you can note down this table so that you can remember. Clear?
Yes.
So this is about AND operator. Likewise, next comes logical OR operator. This is the symbol of logical OR, double piping symbol. Double piping symbol. This symbol is called pipeline. It is just below the backspace key in your keyboard. Okay. In our keyboard, there is a backspace key. Below that, this symbol is there. If you type 2 times, this symbol comes like this, double piping symbol. So what it will do, just opposite to AND. Okay. Suppose there is a expression. In that expression, there are so many conditions. Okay, if all the conditions are false, then only it gives the result as false. If at least one condition is true, means it gives the result as true. Okay, just opposite to and. So according to whatever you have written the definition of and, can you say what will be the definition of or?
It gives logical values if one condition in an expression is true.
What you written for and, just opposite. Wherever there is true, make it false. Wherever there is false, make it true. And read.
It gives logical values if all conditions in an expression are false,
In,
otherwise it gives true.
see, in and operation, you should left one word. It gives logical value false. Have you written? It gives logical value false if all conditions. So what you written? I can't. Ah, it should be like this. The definition of and should be like this. Check again. It gives the logical value true if all conditions in an expression are true, comma. Otherwise, it gives false. Is it okay?
Yes, sir.
Now you say the definition of or.
It gives logical value false if all conditions in an expression are false, otherwise
X
it gives true.
exactly. Getting it? Just stop. You can note down. So clear?
Yes, sir.
So have you understood why it is defined like that? If all conditions are false, then only it gives false. If at least one is true, means result is true. Okay. In case of OR operator, if at least one condition is true, means result is true. Okay. If all are true, then obviously result is true. When it gives false, when all are false. Okay. So now, as we have done one table for and C1, C2, okay, and R, clear? You make a table for or like C1, C2 and R. Use instead of and symbol, you use or symbol, and you put the values as it is in and operator for C1, and you put the values as it is in and operator for C2, and the R value you get and assume and write yourself. C1, C2 values you put as it is in and, but R value you what it.
Yes, sir.
Yeah, like that in copy.
So done.
Done. Now check. Is it showing like this?
Yes, sir.
Okay. Sorry. By mistake it is and symbol I have written. That might be or symbol. Okay. So between C1 and C2 that should be or symbol. Okay. And see when it gives false when both are false. Otherwise it is giving true like that. Next comes not operator. Logical not. Its symbol is exclamatory symbol. Okay. So So what it gives? It gives opposite logical value. Opposite logical value in the sense, can you guess? Opposite logical value means if the condition is true, the result will be false. If the condition is false, the result will be true. Okay, like this. It is generally used with single conditions. Okay, you can note down one more point. It is generally used with single conditions. Okay, you can note down. It is generally used with single conditions. Unlike and or operator, that and or operators are used with multiple conditions, but whereas not operator is generally used with single conditions. It gives opposite logical value. Done? Yes. Then see. Suppose there is a condition and a result. If condition is true, result will be false. If condition is false, result will be true. Okay. Note down this one. Hmm. Yeah. So this is about logical operators. Then next comes bitwise operators. So why these are so called bitwise operators? Because it gives bit values. Bit values in the sense binary values, ones and zeros. Okay, what we discussed last class, binary language or machine language or low level language. That language will have these bitwise values, ones and zeros. Whatever you input, that will be internally inside computer will convert into ones and zeros. Suppose if I input 5 generally, but internally that becomes 101. If I input 10, internally that becomes 1010. If I input 7, internally that becomes 111. Like that. That is a binary language. So bit values, ones and zeros. In the binary language, there are only two alphabets, 1 and 0. In English language, we have 26 alphabets. Likewise, in machine language or in low level language or in binary language, there are only two alphabets, that is 1 and 0. So the operator which will work or which will manipulate upon these 1 and 0, that operators are called bitwise operators. Okay. Are you clear why these are so called bitwise operators? Because these are used to manipulate the
Yes, sir.
ones and zeros, the bit values. Okay,
Binary.
binary values. So you can note down it is used to manipulate the bit values like 1 and 0. It is used to manipulate the bit values like 1 and 0. Done? Yes. Then these are, see, 6 steps. Bitwise and, bitwise or, exclusive or, left shift, right shift, one's complement. You can go down. Then
Yes, sir.
yes. So the six types of bitwise operators we have. First one is bitwise AND, then bitwise OR, then bitwise exclusive OR, then bitwise left shift, then bitwise right shift, then bitwise ones complement. So let us see bitwise AND operator. The symbol of logical AND operator is what? Symbol of logical AND operator is?
And that
Yes, double ampersand symbol. Here it is single ampersand symbol. Okay, bitwise AND operator. So in this bitwise AND operator, the single ampersand symbol will use. How it will work? Let us see. Suppose now first give a heading bitwise and within bracket you can note down single ampersand symbol like this. Suppose x equal to 7, y equal to 3, z equal to x bitwise and y. Okay, you can write down in the copy an example. X equal to 7, y equal to 3, z equal to x bitwise and y. Then, so what will be the value of z? How can we get? See, first of all, x value is 7. So let us convert the 7 into bits. So how to convert it into bits? So to convert into bits or to convert into binary language, we have to divide with 2. So 2, how much? 2 3 ja. Yes or no? 2 3 ja 6. Remainder is how much?
one.
Remainder. Yeah. I am noting down in the right hand side. Like that. Again. 2. 2 2 ja. Sorry. Not 2 2 ja. 2 1 ja. 2 1 ja. What is the remainder again? 1.
One.
So this is 1. So from bottom to top we make a arrow like this. So from bottom to top, what we get? 1 1 1 or not? Getting it? 1 1 1 we are getting or not? From bottom to top. So this is the result, binary equivalent result. Now, if you want to get its decimal value, so how to get? See, there are 3 digits. Yes or no? There are 3 digits. First digit is what? 1. You have to
One.
write down 1. Then into 2 to the power. After extracting 1, how many digits left?
Two.
2. So 2 to the power 2. Then plus 1 into 2 to the power, what should I write? 1.
One.
Okay, because after extracting this one, again 1 digit left. Then plus, what should I write? Can you say? 1 into 2 to the power, how much?
Zero.
0. Getting it? So here 1 into 2 to the power 2 means how much? Mm,
Four.
plus 1 into 2 to the power 1 means
2.
yeah. 1 into 2 to the power 0 means anything
1.
to yes, anything to the power 0 is 1. So 4 plus 2 plus 1. Finally, what we get?
7.
7. This is the value of z. Clear? In this way, it will be executed. So, no doubt, when we write x equal to 7, y equal to 3, obviously we will get value of z is 7. But internally, it will work like this in computer. Okay. First value of x is converted into binary, then value of y is converted into binary, then whatever the resultant binary will be retrieved, that again converted into decimal form, and the result of that decimal value will be 7. Clear? You can note down this example. Sorry. I have only converted the value of x into binary, right?
Yes, sir.
I think I have only converted the value of x into binary. Sorry. Again, value of y we have to convert again into binary. Value of y is how much? 3. So 3 also we need to convert into binary. So what we get? 2 1 ja 2. The remainder is
1.
1. No more divisible.
1.
So no more divisible.
No.
No. So now, if you go from bottom to top, what you get? The resultant binary.
1. 1.
1 1. Okay. So for 3 we got 1 1, and for 7 what we got? 1
1. 1. 1.
1 1. Okay. Now if I perform AND operation, logical AND operation, if there is nothing means I can add a 0 or not here. So now if I perform logical AND operation, true true, what we get? True, again true true, true
True.
true false.
False.
So this is our result, 0 1 1. Getting? So this 0 1 1, this is our resultant binary value. In this way it will work. So this resultant binary value, let us convert it into decimal. So how to convert it into decimal? 0 into what? 2 to the power 2,
2.
2 plus 1 into
2
2
to
to the
the power 1.
power 1 plus 1 into
2 to the power 0.
2 to the power 0. So finally what we get? This is 0 and this is
This
0
is 2.
plus 2 plus 1. So how much? I think 3.
3.
That 3 is our result. This 3 is our result. Value of z becomes 3. Are you clear?
Yes, sir.
First, value of x we have converted into bits. Then value of y we have converted into bits. Then after converting the value of x into bits and after converting the value of y into bits, then both the bit values we have performed a logical AND operation. Whatever the resultant bit value we got, the resultant bit value again we converted to decimal form, and whatever the result we get, that will be the value of z. Okay, let us see one more example. Okay, you note down a equal to 7, b equal to 9, b equal to 9, c equal to a bitwise and b. Okay, let us do this yourself.
The 5.
So first what you have done, first of all,
Convert 7 into bitwise values.
oh, first you
Then
converted
9.
7 into bit value. So what you get the result bit values for 7?
111.
Yes, right. Then next step, what you have done, you have converted the 9
9
into
into
bits. Okay, what you get?
101.
9.
Hmm.
How you get 101 for 9? If I divide 9 with 2, okay, 2 4 the how much? 8. Remainder is 1. Yes or no?
1.
Like that. Again, 2 2 the 4. Remainder is
Yes. 0.
0. Again, 2 1 the 2. Remainder is how much? 0. So if you go from bottom to top, what will you get?
1001.
Yes. Like that. Very good.
So the
So
answer would be 1.
answer my maybe 1, no problem. No problem. So this 1001 and your 7 result is what? 111, I think. Huh? 111. If you do, you can add a 0. Obviously 0, 0. Yes, it gives 1. No problem. Clear? So this is how bitwise operators will work like that. You next give bitwise or bitwise or. Can you guess what may be the symbol of bitwise or? Can you say what may be the symbol of bitwise or?
Single line.
Yes, single. So operation is same. Suppose write down x is x equal to 5, y equal to 3, z equal to x bitwise or y. Then say what will be the value of z. See, the only difference is when we are making logical AND operation, here we have to make logical OR operation. That is it.
So 7.
Exactly. Clear? Because first of all,
Yes.
when you convert the 5 into bits, what you got? When you convert 5 into bits,
101.
right? When you
101.
yes, when you convert the 3 into bits, you will get 1 1. So 101
Yes.
1 1. Will you can add a 0 before 1 1. Then if you perform OR operation, it obviously gives 1 1 1. And if you convert that 1 1 1 into decimal value, obviously it gives 7. Clear? So in this way, the bitwise OR operator will work. Then bitwise exclusive OR. Its symbol is like this. This is called carrots. It's like exponent symbol. See, normal OR and exclusive OR. The difference is that in normal OR, if all are true, then the result will be what? If all are true, then result will be what?
True.
True. But in exclusive OR, the result is false. If all are true, then false. If all are false, then also false. So when it gives true, when any one condition is true. Okay, there are two conditions. If one among them is true, then it gives true. If both are false, false. If both are true, then also false. Okay, so that is the difference between OR and exclusive OR. You can note down it gives true if only one condition is can note down this table what I am writing. Is this table visible?
Yes, sir.
Done?
Yes, sir.
Yes. Now, suppose we will do the same example. Again, A equal to 3, B equal to 5, A equal to 3, B equal to 5, C equal to A exclusive of B.
So 6.
6. Okay. Because when you convert the 5, what you got?
101.
1 0. When you convert 3, what you got?
11.
1 1. 1 0 1 1 1. So before 1 1, we can add a 0. So that will give 1 1. Then what you got? The resultant binary value. What you got?
110.
1 1 0. So the 5 equal is 1 0 1. The equal is 1. If we get a 0 here. Yes. 1 1 0. Yes. Done. Clear? So in this way, we can do. Done. Next comes bitwise left. Its symbol is double less than double less than. So it also work with bit values. Actually, in CPU register, the bits will be shifted leftwards, but we need not to remember all that headache. We have a shortcut formula. Whenever you will get this symbol, simply replace it with into 2 to the power n. Okay. You can know that it was left side. Symbol is double less than sign. Whenever we get this symbol, we can replace it with into 2 to the power n. N is the right operand. For any operator, there are two operands. One is left operand, one is right operand. So here, N is the right operand. Suppose we write A plus B. So in the A plus B, what is the operator? Suppose if you write A plus B, what is the operator in A plus B? Yes, so that's it. Suppose we write A plus B, what is the operator in A plus B?
Plus.
Plus. So here left operand is what? A, right operand is B for the
B.
operator. Like here, whenever you get this left shift symbol, you can just replace it with into to the power n, where n is the right operand. Okay. Suppose x equal to 2, y equal to x left shift 3. So can you say what will be the value? Can you say what will be the value of y? See x,
16.
let us see x means how much? X is 2, right? X is 2. And left shift we replace it with into 2 to the power n. 2 to the power n means here the what is the right operand?
3.
So 2 into 8, 16. Yes, right. Like this. Next comes bitwise right shift. Its symbol is double greater than sign. That is double less than sign. It is double greater than sign. Okay. And when we get that double greater than sign, we can simply replace it with that is into 2 to the power n. It is by 2 to the power n. Here again n is the right operand. Done.
Yes, sir.
Suppose write down one example. A equal to 12, B equal to A right shift 2. So what will be the value of B?
3.
Yes, exactly. Clear. Is it clear? No. Next comes bitwise ones complement. Bitwise ones complement. Its symbol is what? Curve symbol. it is just below the escape key in our keyboard. The symbol name is called tilde sign. Tilde, tilde sign. It is just like our logical not of logical not of. So which converts 1 bit into 0 bit and 0 bit into 1. If there is 1, it will convert it into 0. If there is 0, it will convert it into 1. Okay, complex. Suppose you write down x equal to 10. X equal to 10. Y equal to 1's complement of x. So what will be the value of y?
0, 1.
How? That is 10. Okay, that is not 1 0. That is 10. First you need to convert that into binary. Then you have to complement.
So 9.
How 9 is the, let us check. Suppose there is 10. If I divide with 2, how much? 2, 5 is a remainder is
0.
0. Then if I divide with 2, how much? 2, 2 is a
2,
remainder is 1.
1.
If I divide with 2, 2, 1 is a
1.
remainder is how much? 0. So what we get?
1, 0, 1, 0.
1, 0, 1, 0. If you make it complement, 0, 1, 0, 1.
1.
So 0, 1, 0, 1. Okay. So if you convert it into binary, sorry,
5.
decimal, right? Okay. Clear?
Yes.
Yes. So this is how to use the bitwise operators. Done this much. Next class, we will again resume. One of the operators are left, then we will go to the program. Okay. Next class again, I will inform most probably in the morning. We will do. I will inform like today. Okay.